We hear constant fuss about climate change in the media, but is what they're saying really true? To really understand this, we need to take a trip back to the past. The climate has been changing since the dawn of the Earth nearly 4.5 billion years ago. Obviously, humans weren't around to actually measure and observe the climate millions and billions of years ago, and so we need to use other methods called proxies to determine what the climate might have been like throughout history. Various methods exist, from extracting ice cores to analyzing the composition of ocean sediments, in which we're able to look at trapped gas particles and chemicals and determine what the atmosphere might have been composed of in a given time period. The rock record alone gives us evidence of how the climate has changed over the past many hundreds of millions of years. If we look at how the climate has changed over the past 70 million years, based on what we know from these proxies, we see that global temperatures were much higher, on average 15 degrees Celsius higher than they are now. Now, you might be thinking to yourself, this is proof that climate change does not matter, but let's go a bit further in time and see why this is not the case. The temperature of the Earth began to cool for the next tens of millions of years until the earliest forms of human life began to appear about 1 to 2 million years ago. Only 300,000 years ago, the earliest Homo sapiens, our species, were walking the Earth. Now, if we look all the way to today's temperatures, we see that throughout their entire life history, humans have evolved under a relatively small range of temperatures, a range of about 5 to 6 degrees Celsius. In just the last few hundreds to thousands of years, we as humans have developed our societies in such a way that fits our climate. We are a species that relies on stable agricultural systems and have developed infrastructure that depends on relatively predictable weather patterns. So, it's clear that even though the Earth has been much hotter than it is now at some point in history, humans and our civilizations would unequivocally not be able to survive. Also, at this point, I want to make it clear that all these changes shown so far are natural climate change. They're changes that we have observed throughout Earth's history, far before humans were present. What's important to us is anthropogenic climate change, meaning changes that are specifically caused by humans. When we say climate change, we are talking about the anthropogenic one, not the natural one. To the people who don't believe that humans are altering the climate, give me a few minutes to present the science behind how we know humans are causing it, and then you can make your own decision. First of all, I want to make the connection between greenhouse gases and warming. Greenhouse gases have been well documented in their heat-trapping capabilities since Joseph Fourier and Eunice Foote first described aspects of the greenhouse effect in the early 1800s. Basically, greenhouse gases have a specific atomic structure allowing them to shake and absorb infrared radiation, which in this context you can just think of as heat that comes from the Earth. This process all starts when sunlight hits the Earth from the sun. The Earth then warms up and emits heat in the form of infrared radiation. This infrared radiation is then absorbed by greenhouse gases, which shake and re-emit some of it back down to Earth, essentially trapping it in the atmosphere and heating the atmosphere up as long as the greenhouse gases persist. If you need proof that this is actually true, let's look back at the graph from before. If we now add a graph of historical changes in carbon dioxide concentrations in the atmosphere, it's almost astounding how closely the graphs line up. We can see that during any period where carbon dioxide concentrations are higher than normal, temperature is higher than normal, and vice versa. But before we blindly agree with this idea and don't accept anything else, we need to find a way to prove that greenhouse gases cause this warming, and that we're not just seeing a correlation between them. There are a few lines of evidence that we can use to prove causation, aside from the physics I've already mentioned. One line of evidence is that greenhouse gases, and specifically carbon dioxide, absorb very specific wavelengths of light, typically thermal infrared radiation, which I described as heat a second ago. Well, it just so happens that we can measure the wavelengths of heat escaping from the atmosphere. We see that in the specific wavelengths of carbon dioxide heat absorbance, less of that wavelength of heat is escaping the atmosphere, which is exactly what we would expect if there's greenhouse gases like carbon dioxide in the atmosphere contributing to warming. This may not be enough proof for you, but we'll have plenty more to come. For now, I think it's safe to at least say that greenhouse gases naturally cause warming in the atmosphere. Now, we need to look at two things. How is the temperature of the Earth changing, and are humans causing it? If we look at this graph, we can see that since about 1850 to 1900, the temperature of the Earth has been steadily rising. The late 1700s and early 1800s are right about when the Industrial Revolution started picking up steam. This industrialization sparked the beginning of widespread fossil fuel use, primarily emitting carbon dioxide and other greenhouse gases into the atmosphere. For simplicity, we'll call the years before the Industrial Revolution and the years before warming pre-industrial times. Since 1850, the temperature of the Earth has risen over 1.5 degrees Celsius, or 2.63 degrees Fahrenheit. Some of you might be saying, there's no way humans have emitted enough carbon dioxide to cause all that warming. Well, let me break it down into two parts. First, let's prove that this increase in temperature is, in fact, caused by carbon dioxide and is possible, aside from whether or not humans caused it. Over the last few 100,000 years, the Earth has cycled through hot and warm periods known as interglacial and glacial periods, or ice ages. In interglacial or hot periods, the average concentration of carbon dioxide was around 280 parts per million. For ease of understanding, don't worry too much about parts per million. It's just a measurement of how concentrated a gas is in the atmosphere. If you double concentration, you double the amount of a gas in the atmosphere. During cold or glacial periods, the average concentration of carbon dioxide is around 180 parts per million. In the last few thousands of years, the Earth has entered into an interglacial period. During this time, the concentration of carbon dioxide in the atmosphere was right about 280 parts per million. But if we look back to the last few hundreds of years, around the 1800s, the concentration of carbon dioxide has been quickly rising, and if you look at the 2025 concentrations, carbon dioxide exists in the atmosphere at a concentration of nearly 430 parts per million. Which, by the way, is a concentration of carbon dioxide that the Earth has not experienced since over a few tens of millions of years ago. So it's clear that this increase in carbon dioxide is causing the warming. And because it doesn't follow historical trends, the easiest explanation would be that this increase in carbon dioxide is coming from the human emission of fossil fuels. But, as has been questioned for decades, how do we know this isn't just from natural causes? Maybe humans are causing some, but not all of the carbon dioxide to enter the atmosphere. Well, first off, let's establish what we know. We know that the Earth has warmed by over 1.5 degrees Celsius, and carbon dioxide is causing the warming. Now we need to prove that the carbon dioxide in the atmosphere is unequivocally from humans. There are a few clear lines of evidence that prove the carbon dioxide in the atmosphere is from humans. First, we track how many fossil fuels we burn per year based on production and consumption data, and on average, we emit about 37 metric tons of carbon dioxide worth of greenhouse gases into the atmosphere every year. We know, based on basic biological and physical principles, that the ocean and biosphere, plants and animals, absorb about 50% of this carbon dioxide from the atmosphere. Also, it is a well-established mathematical principle that adding 7.8 billion metric tons of carbon dioxide to the atmosphere will increase the concentration of carbon dioxide by 1 part per million. So, if we take our 37 billion tons of emitted carbon dioxide, then cut this in half to account for the carbon dioxide taken out by the biosphere, 18.5 billion metric tons remain in the atmosphere. If we then divide these 18.5 billion metric tons by 7.8 billion metric tons, which corresponds to increasing atmospheric CO2 concentrations by 1 part per million, we see that our original 37 billion metric tons every year would increase the concentration of CO2 in the atmosphere by about 2.4 parts per million. Every year, the concentration of CO2 in the atmosphere changes by over 2 parts per million, so this is exactly what we would expect. There is also another unequivocal scientific proof for the human emission of fossil fuels. The element carbon comes in different isotopes. Isotopes are elements that contain the same number of protons, but different number of neutrons. So, all carbon atoms have 6 protons, but they can be found with 6, 7, or 8 neutrons. These isotopes are called C12 for 6 protons and 6 neutrons, C13, and C14. C12 is the most common isotope of carbon, and is the most abundant isotope, making up about 99% of carbon. Plants, which use carbon to grow, primarily consist of C12 because it's easier to take up during photosynthesis. They also have small amounts of C13 and C14. However, C14 is radioactive and has a half-life of about 5,700 years. What does this mean? If you sample the carbon-14 from a dead plant now, and then sample it again 5,700 years later, there will only be half as much C14, and then in another 5,700 years, there will be half of that, and so on. So, older organic matter, or plants, that become fossilized over millions of years and become coal, will have virtually no C14. What we've seen in the atmosphere for the last 100 years is that the ratio of C12 to C13 is increasing, meaning there is significantly more C12 than C13. In addition, the concentration of C14 is rapidly decreasing. Both of these findings are exactly what we would expect if the carbon dioxide is coming from coal or oil, which are primarily fossilized plants from millions of years ago, because they have higher amounts of C12 and less C14. Now, how do we know this carbon dioxide isn't coming from some other natural source of C12, such as volcanoes? Well, the sources of carbon for volcanoes are much different than for plants. Magma in the mantle is enriched with C13, meaning if volcanic eruptions were to blame for carbon dioxide increases, the concentration of C13 would be rapidly increasing. But this is not what we see. So, now we know unequivocally that humans are causing the increase in carbon dioxide. But maybe at this point you still aren't even convinced that greenhouse gases cause the warming. Well, then I'll explain how every other common argument for natural climate change is wrong. Most often, people argue that temperature increases in the atmosphere are either from changes in the sun, volcanoes, or natural cycles like ENSO. First, the sun argument is flawed in a few ways. The sun has in fact increased in brightness by about 30% in the last 4.5 billion years. But if we look at just the last 2 centuries, when Earth's rapid warming started, total solar irradiance increased by a tiny amount. In fact, in the last few decades, as the Earth has continued to warm, solar irradiance, or the amount of sunlight reaching the Earth, has actually gone down. On top of this, the atmosphere is a really good indicator that the sun's energy is not causing these temperature changes. If the sun was sending more energy to the Earth, then the entire atmosphere would be warming. However, we see that the stratosphere, the second layer in the atmosphere, is actually cooling, so sun changes can't be causing the warming. Next, the volcano argument was proven mostly wrong based on the composition of carbon isotopes it emits. However, I can take it one step further. Volcanoes also emit aerosols, which are small suspended particles. The way they interact with the atmosphere is interesting because they are highly reflective and reflect a lot of the sunlight that hits the Earth back into space. So, if massive volcanic eruptions were to blame, we would likely actually see global temperatures decreasing, and this is supported by many past major volcanic eruptions. Finally, the ENSO or El Niño Southern Oscillation argument is probably the most reasonable. ENSO consists of El Niño and La Niña global circulations, which are shifts in air and ocean circulations. During El Niño periods, global temperatures typically increase. However, during La Niña periods, global temperatures typically decrease. If we look at global trends of El Niño and La Niña, it seems reasonable to attribute the warming to this cycle. I mean, look at it, almost every few years El Niño is hitting record temperatures. But what we're looking at is correlation. El Niño is getting warmer every year not because it is causing these warmer temperatures, but because the atmosphere is already warmer due to climate change. Let's try to make more sense of this. Average Earth temperatures are increasing due to climate change and greenhouse gases. So, of course, every new phase of El Niño will be, on average, hotter than the one before it, because the baseline temperature of the Earth is already getting hotter. Notice how after multiple El Niño and La Niña events, the temperature of the Earth increases during normal years. This wouldn't make sense if El Niño was causing the globe to warm, because we see warming even when it isn't occurring. Also, we see normal years warming even after La Niña events, which would make no sense since La Niña cools the Earth. So, El Niño is essentially just adding onto the warming that is already happening on the globe. I want you to also notice these yellow dots. These are years with volcanoes. Notice how the temperature is decreasing? And finally, the age-old argument. Earth's climate has always changed. Yeah, this is true, buddy, but it's an argument that has been created by people who can't comprehend or visualize the scope of climatic existence. Yes, the climate has always changed, but the difference in today's warming is time and rate. Remember earlier when I said at one point the Earth was 15 degrees Celsius hotter than it is now? Over the tens of thousands of years it took to reach that average temperature, the atmosphere warmed at a rate of about 0.0008 degrees Celsius per year, or 0.001 degrees Fahrenheit per year. Looking even at this little period where we are transitioning from a glacial period to an interglacial period, which took about 5,000 years, global temperatures increased by about 0.001 degrees Celsius per year. When we now look at just the last 50 years, we see that global temperatures have increased at a rate of nearly 0.02 degrees Celsius per year. This is about 20 times faster than both of the previous example periods of warming. In the first example, known as the Eocene thermal optimum, where it was 15 degrees Celsius hotter on average, it took thousands of years to see the warming that we've experienced in just the last century. So, let's go over what we've established. Climate change is real, it is not natural, it is caused by humans, and temperatures are increasing because of fossil fuels.